Yo, Wagwan. Yeah, man, we're back with our CSEC additional mathematics past paper question, all right, from the May June 2019 paper. And it says a right angled triangle XYZ has an angle theta, where sine theta is equal to the square root of 5 over 5. And without evaluating theta, calculate the exact value in third form, if applicable, of part 1 cos theta and part 2 sine theta. All right, let's just represent that right angle triangle XYZ. Okay, so let's draw it here quickly. So this is going to be my triangle. That's one side. This is now going to be my hypotenuse. All right, and this is going to be the other side. All right. Yes, so that is our triangle. All right. And I can put in the right angle here. And let's say this is theta. All right, this is our angle theta. And we have x, y, z. Okay. So it told us that sine theta is equal to the square root of 5. And I'm going to divide that by 5. All right. Now remember that sine theta is equal to what? The opposite side over the adjacent side. So the side opposite to the angle theta is here, right? So it means that this side is going to be the square root of 5, all right? Divided by the hypotenuse. So the opposite side over the hypotenuse. The hypotenuse is the longest side of the triangle, which is the side xy here, all right? So it means that this side is going to be 5. Now I want to find zy, all right? So let me just call it y, all right, small y. And we can find that side using Pythagoras' theorem. So it means that I'm going to have 5 squared, right? Just applying Pythagoras' theorem. 5 squared is equal to the square of square root 5 plus the square of y. That's y squared. So the 5 squared is 25, and that is equal to the square of root 5, which is 5, plus y squared. Okay? My aim now is to solve for y, so that I can find the missing side for that right angle triangle. So I'm going to carry the 5 here to the left-hand side of the equation. It will become negative, all right? So what I have now is 25 minus 5 being equal to y squared. 25 minus 5, that's 20, all right? So y squared is going to be equal to 20, okay? Good. And remember now, when we're finding the square root, all right, so we're going to find the square root of both sides. So if I find the square root of y squared, I will get y. And remember, when you're finding the square root of a number, it is plus or minus the square root of that number. All right. However, we know that all the sides of a triangle, all right, all the sides of a triangle must be positive. So I can say since y must be greater than 0, it implies that y is equal to positive square root 20. Okay, so I can now come up here now. I can come up here now and say y is equal to the square root of 20. Okay, so now that I have a visual representation of the triangle that you're talking to me about, all right, we can now answer the question. So part 1, let's answer part 1. Part 1 solution, we have to find the exact value of cos theta. All right, and we know that cos theta is equal to the adjacent side over the hypotenuse. Let's look back at the triangle. The adjacent side is y, right, which is the square root of 20, over the hypotenuse, which is 5. All right, so I can say cos theta is equal to the square root of 20 divided by 5. All right, now I can simplify this. Remember, it says they want it in third form. So please note that the square root of 20 is equal to the square root of 4 times 5. All right? And remember that once you have the square root of a times b, that can be written as the square root of a multiplied by the square root of b. So it means that the square root of 4 times 5 can be written as the square root of 4 multiplied by the square root of 5. We know that the square root of 4 can be written as 2, right? Square root of 4 is 2 multiplied by the square root of 5. So I can now replace the numerator, which is square root 20, as 2 root 5. So this is now equal to 2 root 5 divided by 5. And that is my answer in third form for cos theta. All right? That's part 1 of the question. Part 2 says we are to find the exact value of sine 2 theta. Let's do that here. Part 2 solution. All right. Now remember that sine 2 theta, there's an identity for sine 2 theta. So sine 2 theta is equivalent to 2 sine theta multiplied by the cos of theta. Okay? So the sine of 2 theta, that's what they wanted. That is going to be equal to 2 multiplied by sine theta, which they told us is the square root of 5, all right, divided by 5. And I'm multiplying that by cos theta, all right, which is just calculated, and that's 2 root 5 divided by 5. All right, let's now do some multiplication here. So I can now write sine 2 theta, all right, is equal to, now in the denominator, I will have 5 multiplied by 5. Okay, so that's going to give me 25. All right, in the denominator, I have 25. Let's focus on the numerator now. I have the square root of 5 being multiplied by the square root of 5. All right, and the square root of 5 multiplied by the square root of 5 is just 5. Okay, so here's a rule that you should know. If you have the square root of a being multiplied by the square root of a, that is equal to a. All right, once the numbers in the square root are the same, that is going to be equal. Why is that so? Because the square root of a times the square root of a can be written as a times a under the square root, which will give me the square root of a squared, and we know the square root of a squared is a. All right, so that is why we will get the value as 5 there. All right, so that's 5 multiplied by 2. All right, that's 10 multiplied by 2. That's going to give me 20. So in the numerator, I will have 20. Okay, 20. Now I know that 5 can go into both 20 and 5. All right, 5 into 25 will give me 5. All right, so 5 into 25 will give me 5. And 5 into 20 will give me 4. So it means that my answer for sine of 2 theta is equal to 4 divided by 5. All right, and that is the answer for this past paper question. Okay, I hope this video was helpful. If it was, please ensure to like up this video, all right, and also comment down below. All right, I am Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.